Hello class, this would be our review. Hello class, this would be our review for our Igneous rocks topic. Inside the crust, rocks components are slowly but constantly changed from one form to another, and process involved or summarized in the rock cycle. The rock cycle is driven by two forces. Earth Earth's internal heat engine, which moved material around the core and the mantle leads to slow the significant changes within the crust. And the hydraulical cycle, which is the movement of water, ice, and air at the surface as the sun is powered. So the rock cycle is still active on Earth because our core is hot enough to keep the mantle moving. Our atmosphere, out, out, our atmosphere is relatively thick and have liquid water. And some other planets, their satellites, such as the moon, the rock cycle is virtually dead because the core is no longer enough to drive the mantle convection and there is no atmosphere or liquid water. So the rock cycle, so the schematic view above and takes place both above and below the Earth's surface. The rock dip is beneath the Earth's surface and under extreme heat and pressure is metamorphic rock. This metamorphic rock can be melted become magma. When the magma cools below the Earth's surface, it becomes intrusive igneous rock. If the magma cools above the Earth's surface, it is extrusive igneous rock and becomes part of the outcrop. The outcrop is subject to weathering and erosion and can be removed, redeposited around the earth by surface such water and wind. As the outcrop is eroded, it becomes sediments which can be buried, compacted, and cemented beneath the earth's surface to become sedimentary rock. As a sedimentary rock gets buried and deeper becomes under increased heat and pressure, it returns to original metamorphic state. Rock in the rock cycle, rocks in the rock cycle do not always make a complete loop. It is possible for sedimentary rock to be lifted back about above the Earth's surface, and for intrusive and extrusive rock to reburied and become metamorphic rock. So, in the discussion of the rock cycle, igneous rocks form as magma or lava, cools and crystallizes. Magma is a molten rock that is most often generated by melting rocks in the Earth's mantle. Although melting crystal rock generates some magma, once formed and a magma buoyantly rises toward the surface because it is less dense than the rock surrounding. It is less dense than the rocks surrounding. When magma reaches the surface, it is called lava. When the molten rock solidifies at the surface, the result of igneous rocks can be classified as extrusive or volcanic. After the Roman fire god Vulcan, so most magma loses its mobility before reaching Earth's surface and eventually crystallize deep below the surface. So, igneous rocks that form from depth are termed intrusive or plutonic after the Pluto god of the underworld classical mythology. So, intrusive igneous rocks remain at depth unless the portion of the crust are afflicted by geological process like folding. As magma cools, once mobile ions begin to arrange themselves into ordinary patterns, a process called a crystallization. As cooling continues, numerous small crystals develop, and ions systematically added to the center of crystal growth. When the crystal grow large enough for their edges to meet, their growth ceases because of lack of space. The rate of cooling is strongly influenced in the crystal size. If magma cools very slowly, ions can migrate over heat distance. Consequently, slow cooling results in formation of few larger crystals. On the other hand, if cooling occurs rapidly, the ions lose their motion quickly combine. These result in a large number of tiny crystals competing for all available ions. Therefore, rapid cooling in the formation of solid of mass intergrown crystals. So cooling rate, the faster the cooling rate, the lesser the finer reduced rocks. The larger the fewer and the larger crystal will form. So vesicular, when gases dissolved in the magma are able to come out of solution, forming gas bubbles inside it. To describe the size, shape, and arrangement of minerals grains that make up a rock, geologists use the word texture. Texture is an important property. It allows geologists to make references about rock's origin. So, based on a careful observation of crystal size and other characteristics, rapid cooling products small crystal whereas very slow and cooling produce much larger crystals. As you might expect, the rate of cooling is slow in the magma chamber that lie deep within the crust, whereas within thin layer of lava extruded upon Earth's surface may chill to form solid rock in a matter of hours. Small molten blobs ejected from a volcano during a violent eruption could solidify in mid-air. So granite and rhyolite, same chemical composition but different textures. Jarrett and andesite, same composition but different texture. Gabbro and basalt, same composition but different texture. Gabbro larger crystal than basalt. So form through two stages of crystallization, where in the magma, partly cooled below the surface of the earth, providing time for the large crystal to grow. Before it is extruded to the surface, forming grain matrix per, per, perperetic texture, igneous rocks be can form either fine grain or coarse grain. So voids created by the rapid cooling which cause air bubbles to be trapped inside. If a rock looks like a block of colored glass with no visible mineral crystals, it has a glassy texture, superficially glassy texture. So glassy texture suggests that it was so extremely fast that no crystal could form. So, so igneous rocks are composed mainly of silicate minerals. So, so chemical analysis shows that the silicon oxygen usually expressed as silica. So content of magma are by far the most abundant constituent of igneous rocks. As magma cools and solidifies, these elements combine to form two major groups of silicate minerals. Uh, the silicate are richer in iron and magnesium. So, olivine, pyroxene, am- amphibole, And by its side, mica are the common dark silicate minerals of the Earth crust. By the contrast, the light silicate contains greater amounts of potassium, sodium, calcium are richer in silica than dark silicate. Light silicate include quartz, muscovite, mica, and the most abundant mineral group of feldspar. So the classification of Igneous rock, this is the following history: uh, slowing course, slow cooling and coarse grain, the fast cooling and fine grain, very fast cooling and glassy silver. As you can see, the matic and the dark colored are the gabbro and basalt. So the and and intermediate color is the diorite and andesite. So the felsic and the light color is granite and rhyolite. So, so very fast cooling glacier is the scoria. So how to classify igneous rocks? So to classify igneous rock, I'd always be the composition of silica content, the texture, and magma formation, and a cooling rate. So a light colored, extremely coarse grained, intrusive igneous rock, most pegmatites are composed of quartz, feldspar, and mica. So you could identify this by using composition of silica content, texture, location, magma formation, and cooling rate. So this would be example of a vesicular fine-grained, dark-colored intrusive igneous rock are composed mainly of plagios, plagioclase and pyre. So composition of silica content, always remember that. Texture, location of magma formation, and cooling rate. A coarse-grained intrusive igneous rocks that are composed entirely of olivine. It may contain small amounts of amphibole, feldspar, quartz, and pyroxene. A light-colored vesicular igneous rock, it forms through very rapid solidification of a metal. A coarse-grained, dark-colored, intrusive igneous rock that contains feldspar, augite, and sometimes olivine. A light-colored, fine-grained, extrusive igneous rocks and typically contains feldspar minerals. A coarse-grained, light-colored intrusive igneous rock and contains mainly quartz and feldspar minerals. A dark-colored vesicular extrusive rock. And not, and lastly, a dark colored volcanic that forms from the very rapid cooling of molten rock material. So uh, this would be the last. Uh, so that would be the last. Uh, this glassy texture. And thank you for everyone who's listening.